Hello and welcome back to the channel. This will be episode 5 in our practice problems for Python interviews and test and exam prep series. And today we'll be taking a look at some trickier string operations as well as a scenario where you might be asked to solve multiple solutions of the same problem. If you haven't seen any of the previous videos for this one, you don't really need to. These are some slightly more complex string operations and then just some scenarios that I've actually had in software interviews. So without any further ado, let's go ahead and get into it. Problem 13. Given a string, return a resultant string where every character inside the string is doubled. Example, pizza turns into PPIIZZZZAA, cat turns into CCAAT. So this is a fairly straightforward one, but if you're not familiar with kind of the concept of for loops or indexing inside a string, it can be kind of tricky. So that's the only clue that I'll give, and if you'd like to attempt this one before we go through it together, I recommend go ahead and pause the video now. Otherwise, we'll take a look at the solution together. Okay. So let's go ahead and get started on this one, and I'm going to start by defining a function that I will call double string. And given an input, we are going to make a resultant string that will start out empty, and we will go through and for I in range input. So we're creating a for loop here that's going to run once per this needs to be length of input. So we're creating a for loop that's going to run once per character in the input string. So if you think about the prompt, what we're supposed to be doing is taking every character in a string and returning it twice. So to make sure it runs the right number of times, you need something that runs once per character in the input string. And what are we going to do in here? Well, we're going to take our result string and add whatever was previously in it to whatever item is currently in that index location I, and we're going to do that twice. So all we're doing is basically taking one character at a time and adding it twice to a resultant string, and then all we need to do is once that's done, we just go ahead and print the result. And that's really it. So let's go ahead and run this function with the two that we were given as examples initially, so we can compare them to what's written up top. Let's do double string with pizza and double string with cat. And let's go ahead and run this and see if I did something goofy or if we nailed it. Okay, so if you see right here, PPIIZZZAACCAATT. If we want to run it with something other than what we already had, we'll throw a few states in there. Ohio, New York. Let's take a look. Even down to the space, what we should see here, yep, you got a 2-character space now, because that still counts as a character in strings. So right away, that's the solution to problem 13. If you did it a different way or you have any questions about this solution, go ahead and let me know in the comments. Otherwise, we'll move right on. So problem 14. Given a string, return an integer saying how many times ABC appears inside the string. So for example, this string, hey hi ABC, AC, ABC, hi, would give you 2 back because you've got ABC there once and ABC there once. So 2 individual occurrences. And then inside this string, you'd have it once. Obviously, if those characters don't appear consecutively inside a string, you'll get a 0 back. So that's all the hints I'll give. If you want to take a crack at this before we look at it together, I recommend pausing now. Otherwise, we'll dive into a solution for this. So I'm going to call this function, I'm going to start just like normal by defining a function, and I'm going to call this one check ABC. That's a good name for it. And we'll take an input just like before. And in this one, we're actually going to be returning a integer, not a string. So we'll go ahead and make our initial counter and we'll set equal to 0. And kind of just like the previous problem, we're going to create a for loop for I in range. But think about the length of this one, because you're not really checking up to the end of your string. You're checking up to the end of your string minus 2 characters, because you're not, if you don't really care if the last character in a string is an A because it's the last character in a string. You're not going to check for a B and a C after. You're already past the length you need. So for this length, we're actually going to do the input minus 2. And that's how many times we want to check if our character plus the 2 characters after it are A, B, and C. And that'll make sense in this next line of code, hopefully. So we're going to say if input at I plus input at I, dictionary, input at I plus 1 plus the input, there we go, at I plus 2. If all 3 of those add together are equal to A, B, C, then we're going to do increment the count by 1, add plus equals 1. Need a colon there. And at the end of this, we're just going to print the count. And that is really all we should need to do. So let's see, what do you, oh, it's just because I used a built-in word. Okay, so let's go ahead and check ABC here. And for the 2 inputs, I'll actually start again by using the 2 given as the parameters, because if you're told certain scenarios and you're told what they should give you, that's not a bad place to start and see if your code's working, and then you can run through some additional scenarios. So let's go ahead and run this, and we'll see if we have goofed it up. And we get 2 and then we get 1, and that's pretty cool. So let's go ahead and change this up and say no A, B, C, and I'll throw some spaces in there, and then I will say A, B, C, A, B, C, B, C, A, B, C, A, A, B, C. So that should probably give us 3, counted kind of quickly. 4, A, B, C, A, B. Oh yeah, no, there's 4. All right, I'm not crazy. Cool. That's funny, actually, BCA twice. I snuck an ABC in and didn't even notice. So this, obviously, this works pretty good. This is an example of how you would sort of check for a substring inside of another string. You can kind of imagine you could set this code up to where if you were given any string and you wanted to check if it was inside of another string, you could set up similar checking code. Even if it was a second input, you could set up similar check code to see if it was equal to your second input string rather than ABC. And you could do a for loop where for however long your input string was, you could break this out even longer. So this has a lot of applications, particularly in things like checking for duplicate entries in a data table or checking for duplicate usernames, passwords, things like that. Checking for a substring is a pretty common and useful scenario. So I'm sure there's other ways you could have written this. If you have another way you prefer that worked for you, go ahead and let me know about in the comments. Otherwise, that's problem 14. Thanks. Problem 15. Given a string, return an integer saying how many times cool appears inside the string. However, if the string not appears anywhere inside the string or cool does not appear, just return not cool. So basically, we're either returning an integer if cool is in the string, telling you how many times cool is in the string, unless not is also in the string, or cool doesn't appear at all, then you're returning text saying not cool. So if you'd like to take a crack at this one before we look at it together, I suggest pausing the video now. Otherwise, we'll go ahead and check out a solution for this. So to start, I'm going to create a function just like always, and I will call it cool or not. And you're going to be given a string. And the first thing I'm going to do in the string, because it makes sense to me, and again, there are so many different solutions to this, I'm just going through one that works for me. But the first thing that makes sense to me is I'm going to check and see if not is in the string, because if not is in the string anywhere, it actually doesn't matter if cool is or isn't in the string, because we're going to return not cool just because the word not is in there. Because the two scenarios are either cool is not in the string at all, which is return not cool anyways, or cool is in the string but not is also in there. So in either case we return not cool. So I'm going to create a true false checker called not check, and we'll have this Boolean variable, and I'm going to check now for I in range, and for this one not is 3 characters. So just like the previous example, our length is actually going to be the string minus 2, because we are checking I and then I plus 1 and then I plus 2 to check for N, O, and T. And we will do the same if string at I plus string at I plus 1 plus string at I plus 2. And if that's equal to not, then we're going to do 2 things. We're going to make the not check equal to true, because we've found not. And then if string is not, oh, actually there's one more condition we want in here too. We want to say and not check is false, because we don't want to keep running this. If we've already found not, we don't want to return, okay, we found not multiple times. Like if you had a string that was not cool, you wouldn't want to print not cool 4 times. You just want to print it once and move on. So we're going to set not the not checker equal to true, and we're just going to print out like defined not cool. But then we have to think about the other scenario. So now if we went through and we didn't find not, then we've got to actually, so we don't want it to be an else, we want it to be at the end of the for loop. We want to say if the not check, oh boy, having trouble writing an underscore. So if the not check is still false after that whole for loop runs, that means that they went through the whole string and didn't find not in it. Then this is where we would want to put all of our cool checking. So in here I can say for, let's say J, just so it doesn't get confusing. You could reuse I, but I don't want to do that. So we'll say J in range, and now we're checking something that's going to be the length of our string minus 3, because now we're checking for cool. And so I'm gonna go ahead and start by copying this guy, because it's actually fairly similar. So if the string at J plus the string at J plus 1 plus the string at J plus 2, get rid of this checker, and we need to add in plus the string at J plus 3. But if all 4 of those added together is equal to cool, then we want our count, so that's another variable we should define initially. Count is initially 0, and we want our count to go up by 1 every time it finds cool inside of the loop. And now what we'll say in here, after the for loop is done, we will say, okay, if count is equal to 0, then we are going to print not cool. Control-Z, and then we will say else print, and we're just going to print count. And actually these should both be inside of the if statement, so that we don't run this guy and then run this anyways. So let's see, that's kind of a lot that we just threw in here, and I'm pretty good at making silly syntax errors. So let's go ahead and check cool or not against a couple strings. Let's do one that just says cool code, man. That should give us just a 1. Let's do cool or not, and we'll say totally not cool, man. That's probably just going to tell us not cool. And let's do one that has to count a few times. We'll say cool, cool, cool. So we should get 1 not cool and then 3 hopefully. Let's go ahead and run this. See how we did. 1 not cool and 3. Hey, not bad for a first check. So this is kind of just what makes sense to me, a good way to do it. Again, this problem has at least a dozen different ways you could go about it, but the basic check is you want to make sure the not condition is not in there before you do all the work to check for cool, because there's really no point in just counting up how many times cool is in there, and you do all this extra computing if not was in there the whole time and you knew your outcome was going to be not cool. It's like trying to check out the wiring for a light switch before you even have like power available to the building, and it's like there's no way to know your wiring's correct if the power is completely off. So that's a little bit of a tricky one, but it's a pretty cool scenario. It kind of builds on the previous example where you check for a string inside of another string. This one's kind of conditional checking and deciding what to do based on a subset. So that's a pretty cool scenario, and hopefully you found it useful. If you have any questions or you think there's a totally better way to do it, just let me know about it in the comments. Otherwise, we'll move on. Okay, problem 16. In the range 1 to 100, if the integer is a multiple of 3, return rocket. If the integer is a multiple of 5, return fizz. And if the integer is a multiple of 15, return rocket fizz. Otherwise, just return the integer. So they're telling you a few things here. They're telling you right away you have to run this loop 100 times. They're telling you what to output. On multiples of 3, print out rocket. On multiples of 5, print out fizz. Multiples of 3 and 5, basically 15, return rocket fizz. Otherwise, just print out the number. So they give you a lot of definition, but there's really quite a few ways you could go about doing this. So if you'd like to take a crack at it, I recommend pausing the video now. Otherwise, we'll go ahead and take a look at a solution together. Okay, so I'm gonna just start right away with a for loop because it doesn't really make sense to create a function for this one because there's no parameter getting passed in. You're sort of told how it needs to run and it's gonna run the same time every way. There's no like given a string or anything like that. So we're just gonna start with a for loop and say for I in range, and it's gonna run 100 times. Starting at 1, going to 100. The cool thing about ranges is it really runs up to that number of times, but it's non-inclusive. So I in range 100 is going to run from 1 to 100, or you can think about it 0 to 99. Either way, we're going to start then by incrementing our counter right in the beginning. Actually, don't need to do that in a for loop. Silly. So what I'm going to do to check is I'm going to check and see if I divided by 3 has no remainder. So this is the Python function for remainder. When you divide an integer, so you got to think this I is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Anytime it is a multiple of 3, the remainder is going to be 0. So first condition was if that's true and if I divided by 5 does not have a remainder of 0. So this is saying it is a multiple of 3, it's not a multiple of 5. Then what are we going to do? We're going to print out rocket, correct? Yeah. And now we're going to copy this condition a few more times because in total there's 4 things we could return, and the basic format is going to be pretty similar for all of them, except the last one will just be an else. So now let's say if it's not a multiple of 3 and it is a multiple of 5, then we are returning fizz. And now you could simplify this to say if it is and let's make these elifs. It should be mutually exclusive the way we wrote our conditions, but we never want this to run and do 2 of these in the same time. So you could write this as if it is a multiple of 15, or since we already have this framework created, you can just do it as it is a multiple of 3 and a multiple of 5. And in that scenario, we're going to print rocket fizz, and otherwise we are just going to print our counter variable. And this should be all we need to run. Let's take a look. There is a chance maybe this is going to run 0 to 99. So let's just run it. That's the nice thing about code. Yeah, so it looks right there like we stopped at 99. So actually the incrementing of the counter right in the beginning is what you want to do to make sure it actually runs 1 to 100 rather than 0 to 99. Okay, so let's go ahead and just look up at the top and we'll scroll through a little bit of it. We see our first text at 3 and we get rocket, which is great because it's a multiple of 3. And then we get at 5 we get fizz, 6 is rocket, rocket, fizz, 3s and 5s, and then let's go down to our first 15, rocket, fizz, that looks good. We see the numbers in between. Let's go down to 30, rocket, fizz, cool. So we can see that code's working pretty well. This is an actual question I got asked interviewing for a Python software position, and you know, this actually goes with the next problem here, but this is just kind of a typical interview question. It's not hard. They give you a lot of parameters and they just kind of want to understand your thought process. So that's one way to do it. It worked for me. One thing about interview questions in particular, and like test and exams where you have a computer in front of you, go ahead and run it and see what you get. And even if you're on an interview, you know, as long as you're familiar with the basic steps of troubleshooting and you can talk someone through your process about how you're going to go through and catch stuff, usually seeing that you're a problem solver with an intention on figuring out what's going wrong is more important to these people than seeing that you ace the code on your first try. So kind of there, how we saw it went 0 to 99 and then quickly fixed it to be 1 to 100. That's a pretty normal thing to have in an interview. So that's my solution. That's my advice to you guys. Let me know what you think in the comments and we'll move right along. Okay, problem 17 is the exact same prompt as problem 16, but now you have to do it a different way. And again, this is actually what I was asked. After creating code and feeling so triumphant about having a solution, the interviewer was like, oh, okay, that was cool. Do it another way, you know, so using a different concept. And that's pretty normal if you write code and you're happy that it works, but then it's not optimized or it doesn't play nice with someone else's code. I mean, typically you don't create software in a vacuum, you're on a team. And so it pays to show you can find multiple solutions to solve the same problem. So I recommend go ahead and try pausing it and doing it a different way from how you did it previously or how we went through it together previously, and take a crack at it, and then we'll take a look at another solution together. Okay, so in my mind, what we did previously is we just did a for loop for every integer, and we used remainders in division to check if we were on a certain count. And what I'm going to do this time is I'm actually going to create a couple counters that you can think of like on a you know, like combination lock. Once you turn something over, right, like you go 0 1 2 3 4 5 6 7 8 9, but it's circular, and you turn it over and the next number is 9. So I'm going to create a couple of counters. We'll do a 3 counter, and we'll call this other one 5 counter. And essentially we're still going to need a for loop, and we can say for I in range 100, or I mean, sometimes they'll say, even, you know, they don't want to see the same for loop, you could just say while I is less than 100, and you just start by defining I as 0, and then while I is less than 100, we'll increment I just like before. We'll and then we'll start doing some checks, and we'll say if 3 counter is equal to 3 and 5 counter is not equal to 5. So we're kind of creating those same scenarios as before, but now we're doing it right with counter variables. And so what we want to do in the situation where we print out rocket, we also want the 3 counter to reset back to 1. And we want the 5 counter to just increment. Okay, so because we're not using a for loop, and right away you can see this is a lot more code. You don't have to worry about, like, if you're asked to provide an alternate solution and it sucks, like it's a worse solution, you don't have to worry about that. I mean, they're trying to see that you can solve something multiple ways. They're not trying to test you and see if there was actually a better solution. So think about the scenario where now we're saying that it's the 5 counter. We want to print out fizz. Let's make it an elif just like before. And now let's consider the scenario where they're both true. And that's when we print out rocket fizz. And both counters get reset to 1. And then the other scenario is going to be none of that's true. And that would be a scenario where we increment both these guys and just print out the counter. So you print I and you increment both counters. And let's check here, rather than spend a bunch of time reviewing if I've missed something, I'm just gonna look at the solution and see if we got it. So the end looks pretty good. Let's go ahead back up to the start and check again. So at 3 we get rocket, 5 we get fizz, 6 we get rocket, 15 is rocket fizz. Let's go 30 rocket fizz, 33 rocket, 35 fizz. Cool. So again, I like the first way we did rocket fizz. I liked the for loop. It was way less code. You can tell just clicking between the two. We did this in 7 lines of code, and we did this in 20. I mean, this is not optimized, but you never know. Like, for the application that you need code written in, there are better and worse solutions, and this is a pretty good example of you're going to be asked to solve the same problem 2 different ways. And a lot of software guys, a lot of tech guys, they get very stubborn and like, well, I know how to solve the problem, but a hiring manager or an evaluator might be trying to see that you can think creatively of multiple ways of solving something. So hopefully you found that useful. You know, if you solved it a totally different way, if you have any questions about anything you saw here, just let me know in the comments. Otherwise, if you found this or any content on the channel helpful, go ahead and leave a like and a subscribe. I really appreciate that. It helps the channel out a lot. And as always, good luck with your code, and thanks for watching. Thanks. Bye.